Okay, here we have a question, and the question is to find the function g of x such that f of x is equal to x cubed minus 3 divided by g of x, given the following conditions. There are no vertical asymptotes, and there is a slant asymptote at y is equal to x. So now I wrote a lesson on this as a document goes here, so if you want to pause and kind of look at this in more detail you can, but the answer to this question is quite simple, but you need to understand the theorems, such as where a vertical asymptote lies. So vertical asymptotes are when the function is undefined and f, this part here, f, the y part, the up and down part in the graph, goes to plus or minus infinity as g of x approaches 0 in this case. But there's other cases, but for this case specifically, when g is going to 0, f of x is going up or down. So for instance, if we had a graph like this, and this is your asymptote, this is your, this up and down, we'll call this f, and then this would be as g of x here is going to 0, we would have something like this going to plus or minus infinity. It can go the other directions, but that would be your vertical asymptote. So we don't want that. That means that g must be in the real number set. That means g has to be defined for all values. So this is what they want the graph to look like, okay? This blue line here is f. So the blue line is f of x, and the green line is y equals x. So that's what we're looking for, and what you need to understand with this question is that when f is going to be equal to your asymptote, okay? F will be equal to your asymptote plus some function divided by g, okay? If we go back to the doc, you'll see this is what I'm talking about right here. This is your asymptote. When you get into this form, this is your asymptote. So you can set this up doing long division. You can get this answer by doing long division. Now, you'll find that you can find more than just a slant asymptote. You can actually find functions that are asymptotic to curves, like a parabola, for instance. You might have some type of a function that is asymptotic to a parabola, and that is also found by doing long division. So basically, just to get to the point here, if we've got y is equal to x cubed minus 3 over g, then we're going to break that apart to x cubed divided by g minus 3 divided by g. And this part right here is not what we want, because this isn't x, right? That's not x. We want x to be in this form right here. We need the x to be right there, okay? So what do we do to make this piece right here equal to x? Well, x cubed divided by x squared would give you x. So then we get x minus 3 over x squared. And that right there is your answer. And you can write it, so we can say, let me get a different color here. We can say, therefore, f is equal to x cubed minus 3 divided by x squared. Now, the method here is basically, it's just called inspection. We solved it by inspection, which means that the problem should be obvious based on understanding what the theorems are and looking at the way it's set up and just some basic algebra techniques. That is what inspection is. You could set this up doing long division and do a whole bunch of other stuff, but that's not necessary for this problem. They literally want you to use inspection, and you may think, well, I need some type of an algorithm to solve this because I'm used to having algorithms and formulas. Well, that's not the case here. They're asking you to actually understand the question. Do you understand the theorems? Do you retain knowledge from the previous courses? So inspection is a key component to solving a lot of problems, basic problems. And then you use that logic to solve more complicated problems when you need to set things up and so forth. So that's all you got to do for that. And